doing today? We're doing many new things. I'm in the middle of testing out this whole thing with D-Wave, right? And so I kind of came to the conclusion after some of the tweets around these that I want to try to compare sort of a D-Wave system solving a problem that can also be solved in something like an IBM machine, and then sort of a gate model quantum computer or QPU, and kind of compare that. And so a bit of doing what I want to compare is I want to compare a D-Wave system solving a QBO, a Qiskit. Apparently, Qiskit can also solve can also solve for QBOs. So IBM or Qiskit, QBO. Apparently, it can also do these. Okay, so an interesting classification problems is research for quantum computing are quadratic unconstrained binary optimization QBO problems. Finding the solution to a cube is equivalent to finding the ground state of a corresponding Ising Hamiltonian, which is an important problem not only in optimization but also in quantum chemistry and physics. For this translation, the binary variables taking values in 0 and 1 are replaced by spin variables taking values -1 +1. Which allows to replace the resulting spin variables by Pauli Z matrices and thus the Ising Hamiltonian. For more details on the mapping, we refer to 1. So, okay, so minimum eigen optimizer. So Qiskit provides automatic conversion from a suitable quadratic program to an Ising Hamiltonian, which then allows to leverage the minimum eigen solver. So it's VQE. Okay. So what Qiskit does is it translates it into something can be solved with VQE. Okay, because it's like what I want to do is translation to an Ising Hamiltonian Qiskit Aqua. So rapid translation to an Ising Hamiltonian Qiskit Aqua, also called operator, the call to a minimum eigensolver, as well as the translation to the results back to the. In the following, we time is it? Whatever. In the following, we'll first illustrate the conversion from a quadratic program to an operator, and then show how to use the minimum eigensolver. With different minimum eigensolver to solve a given quadratic program, the algorithms in Qiskit automatically try to convert a given problem to the supported problem class if possible. For instance, the minimum eigen optimizer will automatically translate integer variables to binary variables or add a linear equality constraints as a quadratic penalty term to the objective. It should be mentioned that Aqua will through a Qiskit optimization error if conversion of a quadratic program with integer variable is attempted. Converting a QBO to an operator. Okay, so here's a way you create a QBO. Minimize linear quadratic. So I guess those are the quadratic terms for the variables. So x times y, x times z, and y times z, and those are the terms. Okay. So what I want to do is I want to take a let's put it this way. So I want to take the example from Chicago Quantum, but like take like a smaller data, like a data set, like with instead of like 40 assets, say, I don't know, even just 5 assets, like something that can be solved. Wait a second. Actually, I wanna let me take a look. So what we wanna do is maybe 5 assets is good enough because we're gonna represent each asset with a qubit. And so what I want to do is I want to actually solve it with Amrock, so I can also then play with Qiskit pools with Q controls, optimized pools technology stuff. So how many qubits has Amrock? Armonk, sorry. 1 qubit? Only 1 qubit? Okay, it's then kind of not good. Then we... Really? You just got 1 qubit, okay. That's not good. Because with 1 qubit, we can't really test the... we can't really test the Q control stuff. But maybe there's a way that we get access to... Okay, that kind of sucks. I didn't expect that. I thought we could do these because what I wanted to do is I wanted to then compare. You know, kind of fine tune the pulses with Q control and see if a Q control enhanced the version of an IBM QPU would yield better results. And by better results, I mean like I'm interested in the quality of the results, so in how like low the minimum that is found in comparison, like between a D-Wave program, an IBM like Qiskit, like in a normal, let's say like I don't know, whatever. We'll pick one of the machines, or Orenso or something. And then I wanted to play with pools, but like I can't really. Maybe there's a way that maybe the IBM people will give me some open pools access to other machines, but I doubt. Seems to be pretty. Well, there's a bigger machine. I'd love to compare that. I really would love to compare that. Otherwise, I'll have to find a smaller problem, and it's not going to be a portfolio optimization problem, which it kind of sucks because I really wanted this to be the portfolio problem. But anyway, what I wanted to do is I wanted to try something a bit different today in terms of kind of following, you know, along the same lines. I'm in the middle of catching up with what the D-Wave system really does in terms of the Cuba thing, and I wanted to run an example today. But it also occurred to me that I might as well try it with Amazon Bracket, which is, you know, it came out recently, as in like I think now they just open it up. So why don't we just create an account there and try to run an example, a D-Wave example, like a Cuba example. So let me create an AWS account because I don't have one with these emails. So insert in systems, gmail.com. I'm not going to use the suggested password because you probably. So you know what? Like I'll actually probably. I'll just take that to another screen so you don't see it. I'm gonna create a password in there. So passwords are not equal. That is not true. Okay. Why is it? Come on. Ow. What is my AWS account name? I'm gonna call it like certain systems or something. Certain systems. Continue. And I'll probably do actually check out the email. So it's gonna be a personal thing. I hope this is available in Germany. Or should I just like, is it available for all the regions or like, I think so, right? I guess. Do I have to in all the address and all the stuff? Work. Okay, cool. Go ahead and create the account, okay. Oh, I got a credit card. Let's do that. but I'm not going to show you guys the credit card. Yeah, so. So I'm basically completing the AWS registration form right now. I was going to verify my credit card, and then basically I'm going to have to go for my phone. Actually, I forgot it somewhere else. So. Sorry, guys, I don't want to show this because it's always going to contain. Okay, so now it's going to send me an SMS. It's weird. It's complaining about a payment problem. Will you just verify my credit card, man? Okay. Let me see. So let's log in. Oh, maybe first I have to verify the account somehow. How can it be that complicated to open up an AWS account? answersystems@gmail.com. Well, yeah, that account doesn't exist. So I gotta create a new account. Oh, sorry, I used the wrong. Sorry. Sign out. I gotta start from scratch. Create an account. Answering systems at gmail.com. That's gonna be the email address I will use. And I'm gonna go ahead. Okay, now I'm gonna create a personal account. I'm gonna add my phone number. This is gonna be Germany, the country. And now I'm gonna get the credit card. I used one that was expired. That is not good, obviously. So now this should be the right one. It's so hot in here today. It's such a hot day. 6. Okay, so and yeah. Okay, so now let's go and get the phone number. So this is going to be this. Trying to check I'm not a bot or something. Okay, cool. Now I gotta go for my phone. Give me a second. cool. So back here. Now I should have gotten the verification code on the phone. So let's input the code. Okay, so this is going to be just me getting the AWS account verified. Okay, so I'm going to go for the free plan. See how much we can do. Okay. Now, how do I get a bracket? How do I get the bracket? Products. Oh, sorry. I should maybe now bring back the screen. Down to you guys in here. So I'm in there, accept all the stuff. So how do I, so probably should go to bracket, to bracket the products, quantum technologies, okay. Get started with Amazon bracket. Learn the best practices to get started with quantum computing with Amazon bracket. So get started with Amazon bracket. I gotta log in again, so let me just in case, go in here. So let's log in. Password. I guess it's loading now. The management console, so cool. Okay, so what do we got here? So we've got built a solution. So that's the management console. I want to go to the quantum staff. Where's the quantum staff again? Machine learning, quantum bracket. Here it is. Oh, are you kidding me? But I can select other regions. Okay, so I can, I don't know. Can I just switch the region? Yeah. Okay. I thought it would be, okay, cool. So getting started with Amazon Bracket. Amazon Bracket provides a development environment to design quantum algorithms, test them on quantum simulators, and run them on a quantum computer. To successfully configure and enable Amazon Bracket, you need to use an account that has the Amazon Bracket full access. You or your AWS admin can attach the policy to your role, user, or group using the IAM console. Account permissions, terms and conditions, I have read and accept all this stuff. Amazon stores the results from your algorithms in any Amazon S3 bucket, starting with Amazon Bracket. To get you started, we can create a new bucket for you. You choose to name your bucket. Okay, just create a new. Enable Amazon Bracket. Let's do this. So what I wanted to do today is I wanted to kind of run. I wanted to run a Cubo example on the D-Wave system that is apparently accessible through Amazon Bracket. Okay, so cool. Okay, so we get now. Okay, so we get the backends here. Online. There's a simulator from Amazon. Then it's 34 qubit simulator. Then there's a D-Wave 2000Q. There's IonQ, and there's Rigetti, the Aspen 8 machine. 30 qubits, 11 qubits for the IonQ. And okay, so next available now. Oh, so this means that the next time is the Rigetti is available is like in a day and 20 hours. It's crazy. Okay, so how do I work my way through these now? So we've got the devices, we've got notebooks. Okay, so here you can create your notebooks. And then you've got the tasks, and I guess this is where you can see the tasks that are running. But you can create your notebooks here. What if I inspect the device, the D-Wave device? Okay, so D-Wave's approach is quantum annealing, which harnesses the natural evolution of quantum states. Each D-Wave QPU is a lattice of tiny metal loops, each of which is a qubit or a coupler. Below temperatures of 9.2 Kelvin, these loops become superconductors and exhibit quantum mechanical effects. The D-Wave 2000Q QPU has 2000 qubits and 6,000 couplers. To reach this scale, it uses 128,000 Josephson junctions, by far the most complex superconducting integrated circuit ever built. The qubits in the D-Wave 2000Q interconnect in an architecture known as Chimera. The QPU architecture is critical to translating a QUBO or Ising objective function into a format that a D-Wave system can solve. Such binary objective functions can be represented as graphs. These in turn can be mapped to the QPU. The Chimera architecture comprises sets of connected unit cells, each with 4 horizontal qubits connected to 4 vertical qubits via couplers. Unit cells are tiled vertically and horizontally with adjacent qubits connected, creating a lattice of sparsely connected qubits. The notation Cn refers to Chimera graph consisting of an n times n grid of unit cells. The D-Wave 2000Q QPU supports a C16 Chimera graph. Its qubits are logically mapped into a 16 by 16 matrix of unit cells of 8 qubits. Okay. Topology. Okay. Oh, the cost. So it's going to cost 30 cents per task, or like 0.00019 cents plus 0.00019 cents per shot. So you get a base cost of 30 cents per task you run, and then like each task, I guess you can give it a number of shots. So for like 1,000 shots, you'd pay like about $2. Okay, not bad. But that's just device information. How much would like a Rigetti cost actually? Oh, it's more expensive. Okay, it's $3.5 per 1,000 shots. Okay, but the base price per task is the same. Next availability, weekdays. Okay, so this really restricted a bit. Okay, that's the reason. It's not because it's busy, it's because it's only available during weekdays between 3 and 7 p.m. UTC. Okay, I get it. And 9 and 11 p.m. Okay. Topology, calibration. Okay, so there's a bunch of technical information about the machine in here. I guess this. Okay, cool. But then I guess we should go to the notebooks. I think that's what we want. Okay, so you can't run on you can't run on a gate model on the weekend. In IonQ, what's the availability? It's weekdays as well. Oh, that's expensive. 1 cent per shot. In comparison, that is actually really expensive. Well, it's like 1,000 times more expensive. Okay, crazy. Trapped ions. Anyway, we can definitely play with it as well. So devices, notebooks. Let's go to notebooks. Because what I want to do is I want to run a QUBO. Let's just run a QUBO, okay? Create a notebook. So we'll call it like a QUBO test, okay? Or just D-Wave test. Instance, I don't know what this is. Instance types comprise varying combinations of CPU, GPU memory for building, running your quantum tasks. I'll just get whatever it's suggested in here. Optional permissions and encryptions, create a new role, use existing role, or okay, create a new role. Passing an Iam Role gives Amazon SageMaker. I've never used AWS to be honest myself, so I really don't know what that is. To perform actions in AWS services on your behalf. Okay. Root access optional enable give users root access to a notebook. Encryption key, no custom encryption key. Network optional, no VPC. What else can you find? Okay, whatever. Create a notebook instance. So that creates an instance, that creates a notebook. Let me open up see if we can open up the light a little bit. I mean, you won't see any big difference because of the background, but I do actually. Okay, so we got here the notebook instance, and now what? Status pending. And now what do I do? URL. That takes me to notebooks. It says pending. Yeah, okay, it's pending. So okay, so that would open the notebook probably, but it says it's in pending. So let's see how long it takes for this to get in something that's ready. What would be the actual D-Wave? So if I go D-Wave, let's go and find an example. I don't want to now go into the paper. I just really wanna. Is this the username? I used that. Okay, so I didn't use the. Oh, I need to go to check my email. I want to just get an example to get it running. Sort of get a basic Cubo example, and then we'll try to adapt this to the paper. But I think I'll go this way. I haven't got any code yet. What about this? Still pending. I hope it doesn't take like. Oh yeah, no, there it is. The D-Wave security code, which is valid for 15 minutes. There you go. Cool. Let's go. How much would it be here actually? So actually I have for free, I don't know, get more time. So how much do I? It's basically up to 20 minutes of access to D-Wave high resolves, up to 1 minute of direct access to D-Wave GPUs. So for free, I get a minute of access per month. If I wanna get like the commercial access, how much is it gonna cost? It's 30 minutes of direct access. It's $2,000 an hour. Okay, it's a QPU hour. It's funny because the Amazon pricing is not based on time. So it kind of feels like it's based on task and basically shots, right? Like, so if I would, like, I don't know how many tasks, I mean, I guess it depends, right? Like if I have really sort of time intensive tasks, it kind of pays off to go through Amazon. Oh, this is this one, because you can even go these. So you go like $335 a month, and then you have 10 minutes of direct access to D-Wave GPUs. Okay. Anyway, I wanted to find an example, right? I wanted to find an example. This is still pending. Come on, Amazon. How long is it going to take? Status pending. I mean, we can go ahead and try to run it here as well, right? Like, let's go to the. So how do we do this? How do I even get started? Explore examples. Let's just get a key, like just whatever example, I don't know. And then we can try to use the same one via Amazon bracket. Knapsack, simple ocean examples, a demo of nurse scheduling model. what are the simple ocean examples? Let's go with these. And so this is now opening up the online IDE from D-Wave. Please, Amazon bracket. There you go. Cool. But still, I think it pays off to kind of play with both platforms, see how it feels. How easy it is to work with Amazon bracket versus directly natively with the D-Wave stuff. So we're down here the notebook, for instance. Okay, so this is redirecting to the notebook. Here we already now. Okay, so we got like the online IDE, and here we have some basic programs. General program Cubo, that's all we want. Okay, so what do we have? This program demonstrates a basic Ocean program that runs a Cubo problem on the D-Wave GPU. Okay, so you import embedding composite D-Wave sampler. I have no idea what this is. Define the problem as a Python dictionary. Okay, so you've got, I guess those are the variables. And I guess if you just say BB, this is just the non-quadratic term, so the normal term. It's got a 1, KK, and then A times C, A times K, B times C. Then define the sampler that will be used to run the problem, embedding composite, embedding composite D-Wave sampler. Run the problem on the sampler and print the results. Sample Cubo. Q number reads 10. Are these the shots? How do I run these? Maybe here. So oceans and BQMs we can translate seamlessly between Cubo and Ising models and provide offsets for any constants in our models. But how do I run these? Basic Cubo program. So we've got the file provides a basic Ocean program that runs a Cubo problem on the D-Wave GPU. In this example, we use Ocean's embedding composite to determine the best placement of our problem onto the physical hardware. Okay, program characteristics model QBU, Cubo, sampler, D-Wave sampler with embedding composite. Optimal solutions are these ones, and okay, yeah, sure, but can I just run this and that's it? Like, what happens if I click run? Okay. So it's basically found these, but how do I know, has this run in the actual hardware? I guess yes, because it's a D-Wave sampler. I guess that's what. So ABCK, energy -1. I don't know what NAM, OC, and chain are, but like, are those the, so the solution 1001 and then 0110 are the two solutions that are found. 1001, 0110, yeah, those are matching the ones from the README. Now, how do I know? Can I go and check on the dashboard if there's been any? Okay, so 0.02% used. Is it true or direct QPU? Yeah, one problem submitted. I've got still like 59.9 seconds available. Roughly 4,588 per. Okay, so how much would I pay in the Amazon bracket for these? How do I? Okay, so now I gotta go to brackets. So I've played with this basic system, with this basic example. Okay, Now let me go here. Bracket examples. What do we have? Quantum annealing. I want to have D-wave anatomy. What are these? So these are actually HTML files, some background, some annealing background embedding. Okay, so there's some learning material in here. Import and setup. Embedding on a chimera graph, the minor embedding problem. Okay, those are too complicated. Modify the cubo. Is there anything else simple? There's a lot to go through here. That's cool though. Anatomy, graph partition, some cat, vertex cover. Oh, sorry, those are just the HTML files, but here we have the actual notebooks. But what I want to do is I want to run the exact, like that exact problem. So how do I do that, right? So I'm doing some importing. I guess I can't just copy paste that. Somehow I have to, I guess, specify the backend. So is this loading or what? Yeah. In this tutorial notebook, we dive deep into the anatomy of quantum annealing with D-Wave on Amazon Bracket. We introduced the concept of quantum annealing as used by D-Wave to probabilistically find the approximate optimum to some optimization problem. We then discussed D-Wave's underlying chimera graph, explained the problem of finding an embedding of the original problem onto the sparse chimera graph, and discussed the distinction between logical and physical variables. Finally, we solved an example cubo problem to analyze the sampling process and provide a breakdown of the QPU access time. I mean, let's jump directly to the example. I have no, like, okay, embedding, blah, blah, blah. Maybe I can just, tweak the example. So, so there's actually some simulated annealing. Quantum annealing on D-Wave. Oh, here we have what it seems to be. This is what seems to be the part that we've just run. I don't know how much money I'm spending though. I mean, that's a really small. It's 10 shots. Okay, it's 30 cents. It's 10 shots. It should be really cheap, actually. Should I var type diamond spin? Like, so it's getting a sampler. It's doing an embedding composite, and then it's sampling the stuff. Can I just not like? Can I create a cell below? Maybe I'll just bracket you. Okay, so basically the sampler is so it's the actual device. So that's the only thing that should change in theory, right? So, but DUF.system embedding composite, like that's not here being imported. Embedding composite, has it been imported somewhere else above? Oh, yeah, in the very beginning, actually, is it? Oh yeah. So I mean, let me run the imports first. Okay, so let's just run the imports. Least, and then okay. So actually, you got to go through select an S3 packet to save the output. I guess that's all prefix for my stuff, right? And set the D-Wave device. We'll do that as well. Cool. Now I'm not going to go in here. Okay, so we've done the basics, basic import stuff, and now we're going to go and actually I'll just do it up there so I don't get lost. I should. I'll just do it up here where just did that. So I'm going to go and now say create another cell. And so this is just going to be has the same example cubo as in the wave. So what I'm gonna go ahead and do is basically copy these. Copy paste programming. So we have okay, but instead of a D-Wave sampler, can I not just use the device? Oh, now I have to go back down there where I found these actually. Here. Oh, so I gotta do it this way. You know, I better. So they define things a bit differently here, but so they do this die-mode binary quadratic model with the linear parameters, the quadratic parameters, the offset, and the var types. But let's see if that just runs with these 3 lines of code, to be honest. So I'm just gonna copy paste them. Go back to the top. And I'm going to change these. So we're not going to use this sampler, we're going to use our sampler, which is bracket D-Wave sampler, S3 folder, which we've defined here. The bracket D-Wave sampler is in here, Ocean plugin. Okay, and we're gonna, so the BQM, I guess this is, okay, so that would be the equivalent of these sample, Q, samples. I'm assuming that is Q. I'm assuming this should be Q, and then we're gonna give it number of reads 10, and we're gonna comment that line. And so, will this work? I don't know. Embedding composite, I guess. So let's give it a try. We will never know otherwise. Okay, error. The dictionary has no attribute quadratic. Okay, it seems like the okay. So what if I give it these? Maybe it's just the method is different, right? So I'm gonna give it the same method name. Why? Ignored, embedding, response. Sample QA is implemented. Caller doesn't have access to Amazon bracket, or it doesn't exist. Okay. Validation exception. The self in this scope is referring to the basic line. The caller doesn't have is something to do with the rights, I guess. I don't think I'm gonna find any basically help for these, but like I guess it's a rights thing, right? It's not like a if I go to the sampler part, it was down there. Here's an example. Quadratic model. Linear break. Quadratic. Okay, so this is the way it's defined. Okay, let's try to do it this way. Sample model. So they define the quadratic like these. Okay, so basically you've got a dictionary for the quadratic terms, dictionary for the linear terms, and then offset 0, whatever this is, and then, okay, and then it's just doing it this way with a, so you actually define the spin as the variable type with +1, -1. Here we have like ones and zeros, but that should be then just a matter of converting these. So I got to turn this into 2 dictionaries and then offset, and then basically take that that model. So if I go back to my part in here, so that should say model, right? And I should define the model not like these, but basically by saying, you know, so linear is, so linear is basically, and then quadratic is dictionary, and then offset, we're just going to do, and for type, we're going to do, what was they used? They used dymo.spin. Dymo.spin. And so I guess the linear terms, I will use just, how do I do this? So I guess I'll just, instead of B, maybe I can do that this way. And I can say it's B, so it's 1, K is 1, and that's it. And then the quadratic terms basically are these terms. So I would just like this. So this is it, and then this is it, and then I'll just do it like that. So now we've got linear, quadratic, and we're doing 0, 0 diamond spin, and then we're doing sample on the model, number rates 10, embedding composite sampler, and the sampler is the bracket D-wave sampler. Problem is now, so color doesn't have access to Amazon bracket, or it doesn't exist. So, okay, so there's something wrong with the, there's something definitely wrong with, let me just copy paste that so I just don't lose it. Copy paste here. I think there's something wrong with the rights. When I went in here, maybe I gotta just, maybe I haven't run something. I've run these, and now I run that. So this all seems to be running. That graph. So this is showing me a plot. Let's maybe go to. It's good to do maybe with the rights when I created the notebook. Is it possible? Because it says here when I create a notebook instance, passing an Iam role gives Amazon SageMaker permission to perform actions in other AWS services in your behalf. Creating a role here will grant permission to subscribe with the Amazon Bracket full access IAM policy to the role you created. Okay, but how does these, so my account, like, give users root access to the notebook. Hmm. How do I get this to work? How do I get this to work? Enter a custom using existing role. Okay, yeah, but that's the Amazon Bracket Service SageMaker notebook role. IAM role. Create a new role. Amazon Bracket roles. Amazon Bracket. What if I go and run another notebook? That's the, is it the, maybe the device should be, I guess, correct. This is everything generated by themselves, but it's telling me that the call doesn't have access. Some bracket. I just don't know how to set this up correctly, probably. Here is how where do I even search for these? So permissions and encryption. Maybe I should go to somewhere like, I'll just go and actually open this app somewhere else. So just in case I don't want to feel any sensitive information. So bear with me for a second. I want to go to the config, my account. So, because if I create the notebook instance, Amazon bracket. Okay, get started. Yeah, I know this, but that's not get started. Come on. How do I go to the notebooks? What can I do? Actions. So I can stop the notebook. So billing is billing. roles. Man, that's complicated. It shouldn't be that complicated. So Amazon Bracket provide fully managed notebook instances that run Jupyter. The notebook instance come pre-installed with Amazon Bracket SDK and includes tutorials and example algorithms. Amazon Bracket notebooks are based on SageMaker notebooks instances. Learn more. So I'm going to create another instance, D-Wave test 2. I'm going to say, I'm going to keep that like these. Passing an IAM role gives Amazon SageMaker permission to perform actions on other AWS services on your behalf. What is an IAM role, first of all? What is an IAM role, AWS? Scale mechanism provide the best control your S3. Just ebook. Oh, come on, I don't want an ebook, man. Here. An IAM role is an IAM identity that you can create in your account that has specific permissions. An IAM role is similar to an IAM user, and that is iOS identity with permission. Okay, so I probably have to create something first. Being uniquely associated to one person, you can use roles to delegate access to users. Blah 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 blah. How do I create one then? Creating roles. Creating a role to delegate permissions to an IAM user. To an AWS service. That's what I would do. So many AWS services require that use roles to allow the service to access resources and other services on your behalf. A role that a service assumes to perform actions on your behalf is called service role. Blah, 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 blah. So to see what services support using service link roles or permissions to allow an IAM entity to create a specific role. No, but I want to create a role myself. Okay, so create a role for an AWS service console. Sign into my managed console. And open the IAM console. Okay. In the navigation pane of the IAM console, choose roles and choose create role. Select type of trusted entity, choose AWS service. Okay, so roles. So this is the role that I created. Maybe I can actually permissions, Amazon bracket full access. It's got it, so all resources on bracket. It seems this role bracket full access. So it's got everything, right? Or should I create a new role? So this is based on what we said. This is on somewhat It's complicated. If possible, select the policy to use for the permissions policy. Create a policy to open a new browser tab. What service should I mean, SageMaker. So this should. Maybe I don't give it root access, but create a new role. Use an existing role. So what if I use this existing role for the DWF test? Create another notebook instance. That's pending. Bracket examples. This is where I was. Advanced circuits, quantum annealing. Can I run something else like? No. Quantum annealing. DF anatomy. This is where I am. I have no idea. Color doesn't have access to Amazon Bracket, or it doesn't exist. Sampler. Maybe. Okay, maybe this is what needs to be changed somewhat, like IRN, AWS bracket. Maybe this should be somewhat the. Maybe that's what's not working. So I should use the what's the role? Where am I? Creating a role. I want to see the roles that I have, and I don't want to create a new role. How do I know what roles do I have? How much time are we already recording? Give me a second. Okay, about 1 hour, so I'm gonna finish soon actually. Roles. Role name. Users. No users. Bracket US. Okay, how can I? Maybe it's in here. Okay, so here there seems to be some tutorial. Oh, look at these. Get the account. So you gotta do. Yeah, so you actually gotta do. Okay. So import the relevant rules. AWS account ID. But from where do I do these? Get caller identity account. Oh, maybe so get the account ID. Amazon bracket, my bucket. Why is the account ID needed though? Where is account ID used? As part of the bucket. So I'm here, and I'm basically, okay, so that's already, okay, that's done here actually. So if I print the my bucket, it's not defined. So first I'm running these. No, sorry, that's maxcat. Oh, no. This is what we're gonna do. Here's what we're gonna do. We're gonna do print my bucket. Amazon bracket. But maybe that's the problem. Is that that's not the bucket that's created, maybe. How do I know? How do I know? Because when I created a notebook instance, it Amazon bracket instance name. Should close some stuff. Give me a second. So Amazon bracket. That's the wrong thing, right? It should be. I called it because the thing is, I called it. I called the bucket like the notebook instance. Wait, what name did I give it? D-Wave notebooks. So yeah, okay. So this is what I call it. So maybe this is what I have to change. So my bucket is basically so my bucket is Amazon bracket. So it is. I don't know why F though. So that's the stuff that I should change. So let's go and start from scratch. So we import these. Now this is the bucket name, and now this is the device, and now this is the problem. So a caller doesn't have access to Amazon bracket D-Wave test, or it doesn't exist. Is it that I have to create this bucket? Oh, maybe I actually have to create this bucket. So maybe I should go here. Exactly, I should create this bucket. Maybe that's the first thing. I haven't created an S3 bucket. Maybe that's what's complaining about, right? Maybe. So how do I do this? Services, there should be an S3 bucket, right? It's my first time using these, so okay, yeah, there's like create bucket. So bucket name, we'll give it this name, or let's just use these, right? For some reason, Okay, copy bucket ARN. And now I'm gonna say wait, bucket ARN. Okay, so or maybe without these, right? I don't know, to be honest. Is this working? Oh, yeah, nice. Okay, got it to work. Um, it's interesting. So the solutions are so the problem was the S3 bucket. The one that was created by default was like it had a different ID. I guess it had an ID that was my user ID, but now because I created a new user for the notebook instance, then it just the whole thing here doesn't work. Like these AWS account ID, because I guess it's getting, I don't know. We'll see. Okay, but I'm getting the right solutions. So -1, 1, -1, +1, +1, -1, which is equivalent of like the 0, 1, 1, 0, or the 1, 0, 0, 1. I don't know what it was. Was it 1, 0, 0, 1? But the energy is different. That's interesting. -1, and then num OC. It's the same number of everything reads and stuff. So energy is -6 in here, and 8200. That's the same, 8200 binary. Oh, but that's spin. Okay, because we've used diamond spin thing here. What if we try the exact other way? So I do these and I use sample. Sample is sample. No, sorry. Here, sample cubo. Sample cubo. I'll call it Q. I give it these like that. I'm not defining the model. I'm getting the sampler. I'm doing the embedding. I'm calling sample cubo like that. See what I get. I get the same. Yeah, okay, now I get the same. But it says num OC is 5, but the energy is the same. So the energy seems to be 2 rows, 10 samples, 4 variables. 2 rows, 10 samples. What was the -1? Here, sorry, 2 rows, 10 samples, 4 variables. I don't know what the num OC is, though. But I seem to get the same energies. So, okay, that's good. Okay, we've run a basic simple one. So how can I figure out how much did this cost me right now? Services. Can I go to billing or something? Or there's an invoices. Let's check. How much is these? Cost Explorer. Payments, no credits, bills. How do I know how much these cost me? Can I know these? Cost Explorer. It needs 24 hours, budget, saving plans, cost and usage reports. Can I know how much these cost me? What if I go to bracket again? Tasks. No tasks. Maybe I didn't really run it in the real machine. No, I think I run it in the real machine, right? But I haven't created tasks. I don't know. Have I run it in a real machine? I mean, it seems like it's the GPU. It doesn't seem like there's any simulation going on here. maybe I can't just know the costs like that. I don't see the tasks. I don't see the tasks. Why I don't see the tasks? I thought that was a task, but maybe that's not a task. But it is a task, is it? So anatomy. Let's go down here. Cubal problems, problem setup, classical benchmark, response, response aggregate, exact solver. To this end, we analyze the breakdown of the QPU access time as a function of the cubal problem size and parameters we can set as parameters. There's a lot to explore here. Experimental runs. I want to know how much money I've spent, and I don't. But this must have run on an actual device, right? I just hijacked this. I just hijacked this notebook, so like bracket D-Wave sampler, bracket sampler. Here's device. So this is the device. This is really the device. If I go to device here, this is the this is the device. Yeah. Here you see in the URL, that's the device. That's the device. That's not the simulator. The simulator is Quantum Simulator, Amazon. But I don't really see my tasks in here. Maybe it just takes like 24 hours for the data to pop up here. So we'll see. Anyway, I don't know. I feel a bit overwhelmed, to be honest. It's quite a big, but I think I have done it. I think I've run an actual Cubo via Amazon bracket on an actual D-Wave machine. And I basically found the values of these. Yeah, I guess we'll take it from here. Okay, so the next step is how do we actually. I want to give it a couple days, maybe see if I get the costs in there. It seems like I'll probably use the D-Wave free time that I have in here, right? So here at least I have some free time and I can see live how much I've used of my monthly budget. But it was interesting, nevertheless. Okay, so yeah. What now? I guess next is I'm gonna go back to the paper and then try to see how can we implement the Cubo actually. Okay, so that's the first thing. How do we implement the Cubo? So probably next video will be much more, kind of going back to the paper and trying to understand how the Cubo is built, and then try to build it for the D-Wave system, try to build it for the Qiskit, stuff. And I think that's going to be, that's definitely going to be a long project. But I'm here to get and go through these with you guys. I hope this is being helpful. It feels a bit tricky. I really don't know what I'm doing, whether I'm spending a lot of money or not. I just put my credit card in there. I hope my bank doesn't call me tomorrow and says like, "Hey man, what's up with these quantum stuff on your credit card?" Yeah, cool. I hope that was useful, and see you next time.